Hi, and welcome to 1.1 measurement. Students will be able to convert between units and estimate the value of a measurement. The do now we did together in class. This is a video that is in the extension folder. It's like old school. I remember watching it when I was in physics. It's really good. It shows the different powers of 10 as you zoom out into the galaxy and beyond, and then they zoom in and going at powers of 10, which is really cool. So measurement, these are the SI base units. These 7 base units are used to describe every quantity in the universe. So length is measured in meters, mass is measured in kilograms, and time is measured in seconds. So those are the 3 that we use the most often in this class. And you could remember MKS, not MGS, so kilograms, not grams. When you plug in these numbers into the equations that we'll be using, you want to use meters. Make sure it's in meters, not centimeters or anything like that. And you have to make sure it's in kilograms, not grams. So that's the only one of these base units that's actually using a prefix, kilo, instead of just a base gram. So kilograms, very important. MKS, you could remember that. Electric current, we talk about in unit 11 when we do circuits. That's measured in amps. Temperature, the base unit is Kelvin, and luminous intensity, the base unit is a candela, and the amount of a substance, you might remember from chemistry, amount of substance, that's measured in moles. We will not be talking about moles in this class. Mostly meters, kilograms, seconds. So if you were asked to describe the length of your desk, you might use a meter. But what if you were asked to describe a longer distance, like between White Plains High School and Roosters? You might use a kilometer instead of a meter because it's more convenient. So scientists use these prefixes to make measuring things more convenient. You wouldn't measure the diameter of a star in meters, right? You'd use a more appropriate unit. So where are these prefixes for the powers of 10? They're given to you in your reference table, and here they are in the bottom left-hand corner of the first page. So the way this table works is it gives you just the prefix, and you could say that 1 tera, let's call it a 1 terameter, is equal to 1 times 10 to the 12, or just 10 to the 12 meters. So one of these prefixes is equal to this many base units. Another example, 1 centimeter is equal to 10 to the negative 2 meters. So if you think of a meter stick, 10 to the negative 2 is a small amount of a meter stick. So 10 to the negative 2 meters is equal to 1 tiny centimeter. That's how this table works. So 1 nanometer or 1 nanogram is equal to 1 times 10 to the negative 9 grams. So it's important to know how many of one thing is equal to the other when you do dimensional analysis and stuff like that. So these are just some examples to give you an idea for when you're estimating values. You do not need to memorize any of these. I think it's just kind of cool. 1 picogram is the mass of a bacteria, 1 nanogram, human cell. You could see the rest of these. This is like the biggest tree in the world, 1 gigagram, and 1 teragram is the Great Pyramid of Giza. You could do the same thing for time. So 1 nanosecond is the time it takes light to travel 1 foot, and this is actually a super high speed video of light traveling through a Coke bottle, which is about 1 foot long, so that's kind of cool. Some more examples here. Here's a hummingbird. Oops. And then here we go with kiloseconds. Megaseconds, gigaseconds, and teraseconds. I like to talk about this because you might have heard of kilobytes, megabytes, gigabytes, and terabytes on like a computer storage information. So analogy to a kilobyte would be a kilosecond, which is 16 minutes long. Analogy of a megabyte is a megasecond, which is not 16 minutes, but 11 days. A gigasecond is 31 years. So you can see it jumps up 3 powers of 10 difference. 1 terasecond is 31,558 years. So comparing the size of like a kilobyte to a terabyte, 16 minutes to 31,000 and some odd years. This will also be in the extension activity folder. It's a website where you can like zoom in and out, and it's just like a cool way to talk about measurement. There's some example problems in this PowerPoint. I see we're already 5 minutes in. So I think you already know how to use the acronym method. It's basically just King Henry doesn't usually drink chocolate milk. And if you're in centimeters, centi, and then you want to go to meters, here's the meter. So 1, 2. So you go 1, 2. You've probably seen that before, 2.25 meters. And you could do the same thing, 70,000 grams into kilograms. So here's grams, here's the prefix kilo, 1, 2, 3 to the left, 1, 2, 3 to the left. So that's 70 kilograms. I like talking about this one because in your textbook, they say like the average mass of a student is about 70 kilograms. So that's good to know for when you're being asked to estimate values. A student or a person is typically around 70 kilograms, something like that in that area. But what if you wanted to convert kilograms into this weird thing? This is a microgram. So this is the Greek letter mu, just like this is the letter K. The Greek letter mu is for micro when we're talking about prefixes, and you don't see it anywhere here, so you'd have to use this. These two things are in a Word document that I'll have in Schoology as well, so you don't have to write this down. But this is how it works. It goes, so here's micro, and I don't know if you can see that, but it says 10 to the negative 1, negative 2, negative 3, and then it jumps to negative 6. So that's why those two lines are there. So here's kilo. We want to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 7 with 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 micrograms. But who would ever measure the mass of a student like that in micrograms? So the acronym method, all fine and dandy, but what if you wanted to convert something like 15 centimeters into inches? You can't, there's no decimal moving around for that. So you need to know how many of one thing is equal to the other. 1 inch is equal to 2.54 centimeters. So that's cool, but do you like multiply them? Do divide 15 divided by 2.54 or 2.54 divided by 15? You don't have to guess. There's a method. Dimensional analysis. Here's how you do it. You just write the number down with its units, 15 centimeters. Write the number down with its units, please. Then you multiply by some parentheses. Put a line in the middle. Don't make it a distraction because you know we're about to make a really cool fraction. Write the units you just wrote on the opposite side. So 15 centimeters was in the numerator on the opposite side, so that they cancel out, leaving you with pride. Write the unit that you want, we want inches, in the only blank space. Now you're ready for some numbers to take their place. How many of one thing equals the other? I'm running out of rhymes. This was another. Multiply the, so we have to plug them in, right? So 1 inch. So the reason we put the units in first is because that tells us where to put the numbers. So the inches are on the top, so we put the 1 on top and 2.54 centimeters here. This is the step that eliminates the guesswork as to if I multiply or divide. So then you multiply the numerator, then the denominator. Simplifying fractions makes me feel phenomenator. And then so we want to do 15 times 1 in the numerator, so that's 15. And then this is all over 1 times 2.54. Okay, simplify the fraction. You get 5.9. And then you cancel out the units, centimeter divide. So this was 15 centimeter times inches, and then 2.54 centimeters times 1, nothing. And a centimeter divided by a centimeter cancels out. So this is just happening like in the background. And that's what happens when these cancel out and you're just left with inches. Cancel out those units, now you're done. Dimensional analysis makes converting fun. Listen, it's really good to know how to do this. So for example, you might want to convert days. So how many hours are in 7 days? Use dimensional analysis. You write the number down with its units. Then you multiply by some parentheses. You write a line in the middle. And now we have days in the numerator. We write days in the denominator so that they cancel out. And we want to convert into hours. So we write that where there's a blank space. And then you say how many of one thing equals another. I know that there's 24 hours in one day. So this seems complicated, like I'm doing an easy example just to show you the process. So you do 7 times 24, and you get 168 hours. So, like I said, this seems more complicated than it should be, but it'll help you in the future. So a football field is 100 yards long. How long is a football field in feet and inches? Use dimensional analysis. You set it up like this. Yards goes on the bottom because yards was in the numerator here and we're going into feet. I know that there's 3 feet in 1 yard. These will cancel out and you get 300 feet. Then you do the same thing. Feet goes on the bottom so that they cancel out, and we want to go into inches. There's 12 inches in 1 foot. So you do 300 times 12. And a football field is, 3,600 inches long, 3,600 inches long. So there's some more examples here. I'm already 11 minutes in, so you could do this one. Here's another estimating one. So that was the dimensional analysis, converting units. This is what it looks like when we're doing an estimation type problem. You're walking down a city street and are wondering how tall a skyscraper is. You count the stories and determine that the building is 35 stories tall, or like floors tall. What is the approximate height of the skyscraper? And then you have 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3. My first step for these is typically to convert these into numbers that I can more easily comprehend. So 10 to the 0 power is 1 meter. 10 to the first power is 10 meters. Then we have 100 and 1,000 meters. My second step is to try to figure out, okay, 35 stories. If I try to estimate how tall is one story, and think of like a meter stick. All right, how many meter sticks could you fit vertically in one floor? So look at your floor, look at your ceiling. How many meter sticks could you probably fit? It's typically around 3 meters per floor. And if we wanted to convert stories into meters, we could actually do dimensional analysis, or you just multiply 35 times 3. But since we were just talking about dimensional analysis, 35 stories times our parentheses, so we put stories. And then we wanted to go into meters. So we said we estimated one story is about 3 meters. So we'll cancel out stories divided by stories, and we'll be left with 35 times 3, 105 meters. So this is our estimation. Which one of these values is closest? Choice C. So that's kind of my process for doing these. I try to make the answer choices into something that I can more easily compare, and then I do my estimation. So here's another example of a different way they could ask it. What is the approximate diameter of an inflated basketball? Well, if I look at 10 to the negative 2, I might want to move that decimal point over 0.04 meters. But to me, that doesn't help me out as much as looking at the prefixes. And if you look at the front of your reference table, 10 to the negative 2 is centi. So you could actually replace this with the prefix C, and you get 4 centimeters. Replace this with the prefix D for deci, and you get 4 decimeters. This is just 1, so this is equal to 4 times 1, 4 meters. And then 4 times 10 to the 1 is like 10, so is equal to 40. I keep that as 40 meters, okay? If you wanted to, you can convert this further into 40 centimeters, because 1 decimeter is equal to 10 centimeters and so on. So I am still doing the process where like I try to make it make sense to me. I could visualize how big those numbers are. Some people probably could do it like that too, but to me, I like it like this. So now you want to visualize, okay, here's this basketball, and just so you know, like a 12-inch ruler is about 30 centimeters long. So think about that, a 12-inch ruler being 30 centimeters long. If you have a ruler that has inches and centimeters, you could look at it and see, oh yeah, 1 foot is equal to about 30 centimeters. So the answer choice, 4 is too small. 4 meter sticks, that's way too big, and 40 is definitely way too big. This is the best approximation for the diameter of a basketball. There's an exit ticket here. There's going to be a practice worksheet in Schoology, and have a great day.